here to talk today about the communication and storage for applications. I'm Dave Brennan. I'm a development lead in the mobile electronics group. Also joining me here today is Tim Sharp, another developer in our group, who's going to help out with some of the application examples. I want to start by saying that what we're talking about today is communications and storage specifically for applications written for the handheld PC and the palm-sized PC. So the talk is going to be geared towards apps that are running in that kind of platform versus something that might be done in an embedded platform, just to give you a little context. So we're going to start with communication, and then we're going to move on to storage after that. So starting with communications, Windows CE supports the following network protocols you can see up there. There's TCP/IP, IRDA, IRDA, PPP, and SLIP. One thing notable about those two is that currently CE does not support PPTP, and there's still a question about whether or not that will be available in the next version. Currently for the palm size and handheld PC, though, that means you don't have any virtual networking support. And also there's support for NDIS4. That is basically the protocol for the Windows CE file, or not the Windows CE, but the Windows networking file system. On the handheld PC 2.0 and palm-sized PC, this wasn't built into ROM, but it is available as a download off the Microsoft.com site. On the handheld PC 3.0, NDIS is built into ROM, so you plug a network card in and you're able to browse the network immediately. As far as APIs go,
all this does is called socket.
They're APIs for serial communication. Pretty much every device has a built-in serial port, which is used for synchronization and can be used for other serial communications. For IR support, there are APIs for IRCOM and IRSOC, and we'll get into a little bit more about those later on. There are a set of APIs for Windows networking. These are probably more useful for applications that run on embedded devices that are connected to a network. These things are the APIs that allow you to map file shares to a local path. In most cases, you can just refer to the UNC path name of a directory rather than going into this. There is limited support for TAPI on the current devices. Basically, it allows you to make outgoing calls, and that's about it. If you've gone to some of the other OS talks, there's going to be an improved TAPI stack in Windows CE 3.0, which will allow for incoming calls and custom TSPs. Finally, there's WinSock and WinINet. WinSock is the socket-level API that's very similar to the desktop, and WinINet is the internet APIs. And we're going to talk some more about these. There's a couple other communication APIs as well. RAPI, which is the remote API, is a set of APIs that work with CE services. So these APIs are available when your device is connected to your desktop. So these APIs, as opposed to the other ones, are actually run on the desktop, and they basically map to a lot of the internal APIs. You can access databases, you can read the registry, you can get system information, and you can call APIs in your own DLLs. So these APIs are basically used to facilitate communication between your desktop applications and applications on the device.
A couple examples of that, if you've seen the remote tools in MS-DEV, like Remote Registry Editor, that uses RAPI. And another comment is there's currently available a typelib that wraps RAPI calls in a VB6 typelib, so you can call them from even VBA. That means that if you have an Excel spreadsheet that knows about a device connection, you can actually grab the data directly off the device while still inside Excel. So that's something to consider.
And I also wanted to mention Pocket Inbox. Strictly speaking, it's not an API at the same level as the others, but it does allow you to communicate via email. And there's some more information in the advanced talk, and there's also a slide in the basic talk, too, that explains how you can use the command line. Here's a little diagram of how the APIs stack up on CE. Over on the left-hand side of the slide, you'll see that telephony and the serial communications, that's an API that goes directly to device drivers. The other set of APIs I talk about are sort of built into the network stack, and if you care about it, you can look at MSDN. Each of the networking APIs you can map to an OSI layer if you really care to. But basically, you can see here, at the lowest level, we have the NDIS support and the serial link networking, and those pass up. The most interesting thing to note is, from an application point of view, you really don't have to be concerned with the IRDA protocols directly. IRSOC wraps those pretty well. There's also another, the IRCOM API, which isn't directly indicated in this diagram, also uses the IRDA protocols to communicate over the IR port like a serial device. This is just to give you an idea of how the things work together. Let's look at WinINET a little bit. Actually, this slide does not seem right. I think this is a mistake here. Okay, so back to serial communications. So as I mentioned, devices always have one COM port. Like the desktop, the COM port is named COM1, and this is always going to be your hardware COM port. Access to this is very simple. You just create file to open the port, then you read file and write file, and that gets data and reads data to the port. One interesting difference from the desktop, which can affect your input and output, is that you can't turn on async, or as the desktop calls it, overlapped I/O. This means that you can't write a bunch of bytes and expect to return immediately. As I mentioned in the advanced talk, which we're also doing tomorrow, that one way to work around this is to create a background thread that takes care of your reading and writing to the serial port.
Another thing to mention, the IRDA port shares COM1 with the serial port. So if you have one of them open, you won't be able to open the other. That means, for instance, you can't squirt a note to a fellow meeting attendee using IR if you're on a serial connection to your desktop computer.
Yeah, we'll talk about the API for that in a second. Another interesting thing about the COM port in terms of synchronization, when you plug your desktop cable in, you pretty much get an automatic connection and synchronization. That's handled by the rapid communications layer on the device and the active sync components on the device. If you're writing a custom application, you may need to go in and disable the automatic startup of that, because the way things are set up now is the OS automatically invokes the sync components when it detects that serial connection. So if you don't disable that and you have your own custom application, it's going to get blocked off and not going to be able to open the serial port until the sync components decide that it's not really a desktop connection they're making. So here's just an overview of the serial APIs. Basically, as I said, it's the same as Win32 in terms of opening and writing. Even though you don't have the asynchronous APIs, there is a wait COM event API. And basically, you can give it a handle, and it'll tell you if there's activity or not. The get COM state and set COM state, unless you're doing something specific, basically what you can do with those, you can set states like the baud rate, the parity, and other communication state. If you're doing simple communication to a desktop device or another device, most of the time you can set some very basic parameters. Similar for the timeouts, they're just another set of APIs that let you set parameters for those. And finally, one important API is clear COM error. If anything goes wrong, the way the serial drivers work, if anything goes wrong that causes there to be an error, it's going to remain in that error state, and you won't be able to send and receive data until you actually call clear COM error. And read and write will return an error code when those happen. You just need to be sure to call that. I'm not going to go into many examples about serial because I think it's less interesting than some of the other things we're looking at today. So I'm going to move on to infrared communications. So as we kind of mentioned before, the IR port acts just like a serial device internally. There are three different IR options for talking to the device. Raw IR, which most people won't use, just sends whatever you write directly to the IR port. There's no error checking involved. There's no protocol involved. It's just a direct stream of bytes that's written out.
So that's what people call bit banging the IR port, right?
Right.
So if you wanted to, for instance, create a really cool remote control that did a lot of stuff with your television or your whole stereo set, you could write directly to the IR port. And I've heard rumors that some of the devices work, some of them don't. So
yeah, depending on the chip support, some of the devices may not support the baud rates low enough to work with consumer devices. So, for instance, I know that an HP 620 will work, but there's some other devices that if you try and set the baud rate to what's necessary for those, that the bits, it may look like it's working, but nothing will actually happen. For most device-to-device communication, the best option is using IRCOM or IRSOC. IRCOM is just a level above, well, it looks, to the application program, it looks like it's a level above raw IR. It actually uses IRSOC under the covers, but hides all the connection details that we'll show you in an example here. IRCOM gives you a serial port, virtual serial port connection over IR, but it handles all the error checking, all the connection management, and all you have to do is read and write bytes. So for a simple communication app, it's an easy way to go. IRSOC is basically the socket implementation. It's, as you saw in the diagram earlier, it's written above above WinSock, and WinSock has been slightly extended with a new address type and a new socket type to use IRSOC. So we have an example here to show you how this works. Actually, I think I have a slide that I'll talk about first, and we'll show you the example. We're going to do that. And also mention that that in raw IR, since you're just sending straight bytes out, it's not ERDA compliant, but in IRCOM and IRSOC, you are. For the most part, unless you're talking to another ERDA device, if you're talking to Windows CE to Windows CE device, it's going to handle everything for you, including the addressing setup. There's some structures that I'm not going to go into here that you can actually pick the ERDA port that you want to talk to and set those up if you need to talk to a different type of device. But for Windows CE to Windows CE, that is all handled automatically. So for raw IR and IRCOM, these use another COM port. Unfortunately, there's no simple way to get what the COM port is. Typically, these are going to be COM3 or COM4, but it's going to depend on the hardware device. Sometimes COM4 is a modem, sometimes it's the ERDA port. So the trick to doing this is you can actually look into the registry to locate these. I'm going to bring that up. You can show that
keep
up.
talking, I'll look for the registry.
So basically, there's a couple registry keys that indicate where these are at. HT local machine COM IRDA port is the port that indicates where the IRCOM port is, or the raw IR port, and HT local machine driver's built-in IRCOM index says for the other port. One thing to note is that these aren't guaranteed to exist on the device. It doesn't have to support, raw IR doesn't have to support. IRCOM should be there. So, like I said, you're probably not going to be talking raw IR, so that's not going to be a big concern. But for IRCOM, you're going to have to do that registry lookup.
I don't see it.
So you're looking at the COM IRDA. Let's show an example of the device we have here. This is an NEC 800 device, and you can see that on the left-hand side, we're looking under the HT local machine COM IRDA, and there's no port under there because this device doesn't support raw IR directly. If we go down and we look in the HT local machine drivers built-in IRCOM, we'll see that the prefix is COM, which we knew already, and the index is 3. So in this device, it's for talking IRCOM, you're going to just open COM3 colon, and then you can just talk directly.
But this slide says that you have to build that string up by looking in the registry for every device.
You do.
Right.
That's correct. And as Tim mentioned a little bit earlier, the serial and the IR function share a single ASIC. This really means there's one serial chip in the device. And if you're talking to the IR port, you can't talk to the serial port and vice versa. So there's a handy function called escape COM port, and this tells the hardware where you want to direct the COM port to. So you need to call that function before you open one of those. Typically, some applications that use serial won't call that, but you probably should in case that a bad app hasn't reset it back to the serial port. And just like serial communications, switch back to the slides, I'm sorry. Just like serial communications, you open the port with create file. So in this case, we just open COM3, and if another device is in range, and it opened COM3, the link would be established automatically, and you can just read and write bytes.
Where is the slide on IRSOC? We need to talk about IRSOC now.
I think it's a little late. Actually, I'm going to talk about that a little later.
Okay.
Talk real quickly about some of the things in Windows networking. Like I said earlier, the driver and the redirector are built into the handheld PC 3.0, and those are available for downloads for the other devices. If you want to detect if these are available in your applications, all you need to do is look in the Windows directory, and there's basically two DLLs that implement this. Reader.dll implements the file sharing, which is probably what you care about, and NetBIOS implements some of the network drivers, which you probably don't need to worry about. Basically, if both of those are there, you should be able to assume that network connection is available. In the handheld PC 3.0, the file open dialog handles these network paths directly. In the 2.0 version, there's a couple problems, but you should be able to open and save files. The redirector is a client only. You can't share out file systems from the device.
But if somebody can write that, please do. I think it'd be great to be able to put my device next to yours and actually browse your file system somehow. I just didn't have time to write it this week.
The one thing that NetBIOS handles on the desktop is mail slots and name pipes, and those aren't available at all on CE devices. Like I said before, there's UNC naming conventions. You can use the APIs to map them to local paths. If you want to do that, this is documented in MSDN, but they actually appear under a network path in the root. On the handheld PC, the network folder doesn't exist, so if you map directories locally, the user's never going to see those. And finally, it's very important if you're doing network communications to handle the error bad net path return code. That can be returned from a lot of the APIs, the get file info APIs, the open file, create file. You know, basically, if you check that and you get that return code back, you can maybe assume that a net card's not present or the user's not properly connected to the network. So that's something to watch for that's a little different. And if you're just doing general error handling, you might have a specific message for that case.
So in this particular case, the run dialog actually handles that case and brings up an appropriate error message. And as you can see above in the address bar, I'm actually browsing the code machine from the HPC device, and you can see the word CEDemo08. And that's actually saying I'm now looking at the code machine right here. So I have a network card plugged into the device, and we're able to do that. In fact, you can also debug your application over the network cable. Back to the slides.
I just want to mention TAPI briefly to be complete. As I said, TAPI is outbound calls only. Built in is a unimodem TSP, TAPI service provider, which basically handles your standard AT command set. And for most applications, it's overkill. If you're doing something where you want to dial up to a remote system, you can simply use the RAS APIs. Once again, like the other things, it's client support only. This means you can only initiate outgoing calls. You can't set up your Windows CE device as a RAS server yet. RAS, if you remember the earlier diagram, it uses TCP over PGP and SLIP, and again, there's no virtual networking, unfortunately. CE only supports one connection at a time, so if you've got multiple modems, only one of those is going to be able to be active. So if you want to make your application dial, you can just simply call it RAS dial. It's very simple, and the RAS dial API lets you specify a phone number or a phone book entry that the user created using dial-up networking. One example of this, so here's an example of the RemNet application. This actually creates a bunch of phone book entries, and these are stored in the registry. So you don't actually need to look at the registry, though. I'll talk about the API in a second for that. I'm just going to show you another example here. Pocket Internet Explorer, if you've used this, actually has an option to automatically dial when you connect to the network. And what it does is it uses these APIs to figure out how you want to connect. It gives you some serial port, some infrared options, or you can also pick, as you'll notice, any of these dial-up networking connections that the user's created in the remote networking app. And this will determine if it finds out that it can't connect to a certain site, it will automatically call RAS dial to make the connection. This is something you can do in your applications. So the RAS dial call is synchronous or asynchronous, and this isn't actually for reading and writing data. This is just if you want to dial a connection, you can find out immediately, or you can block basically or not block to find out when the dialing occurs. If you do an asynchronous call, you just provide a status call back that tells you, and basically once the connection is established, you'll get a call back or a return from the function that tells you what the status is. And as I mentioned, the RAS immune connections is the way that you can pull back data about what those phone book entries the users created. On to WinSock. Now it gets a little bit more interesting. This is the code that a lot of applications are going to use, especially if you're doing any kind of communication to the internet or other servers. And I'll talk about the IRSock in a minute. I wanted to cover the basic WinSock first so that IRSock would be in a little more context. So as every other slide I have here shows, that it's a subset of the Win32 APIs again. The missing part is WS async select, and this is the API that lets you basically not block on a socket. One way around this again is you can use threads to handle this. You can also set a non-blocking mode on sockets as well, which rather than doing a asynchronous callback, which is what async select lets you do, it will just return immediately and tell you there's no data there. So in a thread, you could do periodically wait and call the sockets on non-blocking mode, or you could put a background thread that just blocks and then signals an event for your foreground thread or your main thread when data is available. One interesting thing that's different from most CE APIs is that the structures you pass to WinSocks are ASCII, not Unicode, which means you need to make sure that you do the wide byte to multi-char, multi-byte to wide char conversions before you call these APIs. There's a slightly different API for ping if you care about that. We've actually recently released a ping utility on the plus pack and PowerToys so that you can, a lot of people ask for this. But just to be complete, there's a couple, basically 3 ICMP calls to ping a remote host. And this might be useful in your applications if you want to find out if a remote host is available or not responding. It's simpler than having the user figure it out themselves, and the APIs are so simple. You just call these APIs and send echo or return and tell you what the status was. A new feature in HPC 3.0 is IP multicast. I don't know of any app that's used this yet, but it's potentially something that could be interesting for broadcasting information to a bunch of people, a net show type of thing, or a chat type app. Finally, WinSock is not a good thing to use for on-device inter-process communication. The reason for this is when a Windows socket is open, it resets the idle timer on your device, and it'll never power off. So if you are going to use it, the best thing to do is make sure you shut these down. Keeping a persistent socket communication between applications is not a good idea.
I got the ping app that you were talking about running and connecting to the same CEDemo 8 machine. So anything you see in the ping app, you can actually write yourself.
Yeah, so
using these.
All we did in this is we just provided a set of combo box that lets you set the options that get passed to those APIs. So when I put a hostname machine and click start, it just fills in the structure with the ping and the usual ping request that you're familiar with in the desktop if you use this. So IRSock is built on top of WinSock. The difference between IRSock is, since it's sort of a pared-down version of WinSock even, there's no support for datagrams, and there's no support for security. The addressing scheme is a little bit different. I'm going to show you that right now. We instead of specifying a whole internet address, the addressing scheme is very simple. It's just the name of the device you're connecting to. And the way you figure that out is there's some special APIs I'll mention in a second. You can basically query for devices that are in range, and it will give you back an array of those. And then you just pick the one you want to talk to, which is typically 1. In the current version of the IR implementation on these devices, it's actually only possible to have 1 IR connection at a time. In the future, that may change. There are some APIs for setting IRDA settings, and these typically, if you're just using IRSock, you're not going to care about these unless you're talking to another IRDA compliant device, and it lets you set all kinds of order parameters, which I'm not going to talk about today. After you connect, it's just like WinSock. You just read and write data to it, and so let's go over the source code and look at that now.
Go ahead. I don't know it. Right there.
So here's an example right here where we're actually creating sockets. So you know one difference if you're familiar with sockets, that we're specifying a socket type of AF_IRDA. This tells the API calls that we're actually that we're initializing it for a socket type of call. You'll notice here that it actually checks for invalid socket to make sure that it's being a good app. WSA get last error is supported as in the desktop, and there's different cases that you can check for here. You should definitely check for those if you're using them.
And it binds to the socket.
I'll show the other example code. What is that?
What do you want?
I want to find the. I'm just going to go to the slide and I'll explain that. You can find APIs. So as I mentioned before, you can find other devices. There's an API called getSockOp, and that exists in WinSock, but it has a special value here, IRLMP enum devices. And that code is the code which returns a list of devices that are available for you to connect to. Let me show you how that looks here. It's very straightforward. So after you've created the socket, you just pass that socket into getSockOp, and here I'm passing in that code here, and what that guy returns is he returns this P device list object, which is just a device list item, and it's just an array of addresses to connect to. And in current devices, you're going to get one back. Once you get that device, what this code is doing right here is he's copying the first device out of the device list here. He's getting the ID out of that, actually. As I told you, you connect by ID. Let's talk about that in the slides a little more. So if there's no device in range, you just want to keep calling this. I recommend putting some kind of interval in there or a wait or some dialogue. Typically, you're not doing this in the background anyhow. If you've used the existing apps, the user says, hey, I want to send or I want to receive. Like regular sockets, you need to set these up so that there's a client and a server. One's listening, and one's a server. The client device is the one doing the polling, and this is going to pick up any servers that are have a listen waiting. So once you have this address back, you create a new address with the AF IRDA address family.
We just talked about that. Socket.
I'll show you that address in a second. Okay. The sock adder IRDA is the type of address, and as I said earlier, it's just simply device ID. And this is just a character string. The device ID is already under the covers. IRSock is taken care of. I mentioned you can do IRDA specific things. This is the LSAP selectors, which is basically a port number. Typically, you're not going to worry about these port numbers because they're going to be determined automatically for you. You have that.
Passing right here.
So here's a sample code in here. Here's the this guy just copies. We've copied the socket address over here, and now that we have the address, we found a machine that's available. We just call connect. We pass in that socket address, and it's a socket adder IRDA. And that structure is simply, as you can see right here, all we're copying in is just this one device ID. And that's all you need to connect to it. You don't have to worry about get host by name. You don't have to map a name into an address. You just specify that ID of what's out there, and you connect. Once you get behind these basics, it's very simple.
And then once you're connected, it's just send and receive like a socket.
So there's a couple things you do have to worry about when you're programming sockets, IR sockets. It's possible devices can go out of range. One user can turn off his device. So you really need to be aware that socket error is a common case. You could be calling send or receive. If you get back socket error, the best thing to do is probably notify the user or just immediately re-enter a polling connection and provide some kind of status of what you're doing.
One of the great examples of the IRDA is in the Hearts game that ships in the game pack. Maybe many of you have seen it. So it's kind of fun to play with another person with another device, except if anybody sneezes and the IRDA connection gets broken, game over, start over. I don't care if you were 5 points away from winning, you have to start over. So that's something that kind of gets annoying if you play Hearts very often, and you can get around that by re-entering the polling loop, as Dave was mentioning.
So one thing you can do in your application, it's really good to call shutdown and close socket when you're done reading and writing. This will avoid a socket error on the other side of the connection. And basically, there's a couple things you can do to terminate gracefully depending on what you want to do. There's two options you can set when you're shutting down. One is SO linger, and this means that you want to wait until the connection's been shut down and everything works. In most cases, you don't need to bother with that unless you really care that the connection was closed down properly. SO don't linger tells the IR sock driver, just do it in the background, take care of everything for me. And for most apps, that's going to be good enough. That's the default option, so if you don't do anything special when you call close socket, that's what you're going to get. We're going to move on to WinINet. WinINet is the library that provides internet functionality.
Take a break.
It's built on top of IRSoc. I think it's one of the interesting APIs. It basically allows you to connect to web servers and get information from them. On the handheld PC and palm-sized PC, there's only support built in for HTTP. If you looked at the Windows CE OS documentation, you'll see that WinINet mentions FTP, but we chose not to build that functionality into the version of WinINet. It's one of the OS components because we wanted to save space. Secure HTTP is supported on these, so it is possible to create secure connections, but caching and cookies are not supported. In most cases, you don't need to handle that. Pocket Internet Explorer handles caching and cookies automatically. It's possible to do your own form of caching and cookies if that's important. In most cases, an application is just going to go to the website. Fortunately, the WinINet does support using a proxy, but it doesn't support the automatic proxy mode that the desktop WinINet does. So you have to obtain this from the registry and set it yourself. And I'll show you an example of how this is done in a minute. And that comes from HKey current user apps Pockets.IE proxy server. So let me show you an example application here.
Want to show yours?
Yeah.
Okay, say I'm on.
So first I'm going to show you a bunch of WinINet examples with this app that I wrote.
Dave's a sailor, and he wanted to write an app that would tell him when it's a good time to cut out of work a couple hours early and go sailing. So he's interested in finding out what the wind speed is and where he wants to go sailing, and his boat's docked near a Coast Guard buoy. So
let me show you an example. Fortunately, the Coast Guard puts up some information on the web that tells us what the weather is at buoy stations all around the ocean in the U.S. So here's an example of one of their pages. You can go to their web page, and here's a list. You can see the diagram up there. All those triangles are various weather stations. The yellows are buoys, and the reds are land stations. So for instance, down here, this red one in the corner here is Smith Island, Washington. I can click on that buoy. It's going to bring me to a web page, and it's going to show me the current conditions at Smith Island. And I can scroll down. I can see some of the conditions about the weather. And of course, the thing I'm really interested in is the wind speed and wind direction. I can tell how fast it's going. It's really a pain. I have to go in and look at this web page all the time to keep updating the data, and I wanted an app that would just tell me what the conditions are going to be like. And I did this using WinINet. Let me switch back over to my device. I've got my little application down here called Sailmon. And just to show you how this works, when I run this, it creates a taskbar icon in the corner that shows me the state of the wind. Right now it's yellow because I'm connecting to the site, and I'll show you the code for that in a minute. It's trying to connect and download those conditions.
So when you connect to the website, you have to actually crack open that HTML page and then just figure out what it's telling you and put it in your dialog?
Right. So let me go back. I just want to give an overview of the app. Let me go back to the code here while that thing is updating. And I'm going to show you where we can. Okay. Let me show you where we handle the proxy server here. So I have a function I wrote called getProxyServer, and like I said, this opens up the software apps Pocket.IE key and returns it. This key basically has two sub-values in it. One is useProxy, and this corresponds to whether or not the user said he wants to use a proxy in Pocket.IE options. And the second key is the proxy server name, which is the actual name of the proxy. So this API, I just return a Boolean, which says whether the user wants a proxy, and a string if there is one. Let me show you how this is used now. Let me go back to the API basic. I'll show you. I just wanted to show you the proxy code, and I'll show you the use of that in a second here. So the basic way the APIs work is everything is handle based, and there's an H internet handle for these. There's in the simple case, you're using two sets of handles. One is for your internet connection, which is an H internet, and one is for your specific web page connection. So Internet Open is the API that gets you an internet connection. It's where you specify the proxy, And once you have that handle, you can then call internet open URL to create a direct connection to a page. After you do that, you can call internet read file to suck the data down.
So open URL returns a handle, and you pass that handle to
Right,
read file?
exactly. And we'll see the code for that in 1 second. The asynchronous operations for this are limited. The desktop WinINet supports asynchronous operations across most of the API set. In this case, you can only use it for the pretty much the internet read file, which you pass it a callback function and it returns data to you. In my example here, I actually decided to use a separate thread rather than a callback because I wanted the UI to be responsive while I was retrieving data from the web. We talk about that a little bit in the advanced talk.
Code. That's not code.
Okay. So here's my code example here. So I mentioned that there's this thread. This routine right here is my main thread procedure, and this is the one that actually goes and gets the data. One of the things I do is I change the icon in the tray to yellow to indicate when I'm updating data, just so the user has some kind of status information. Then I call my getProxyServer type, and if that returns true, that means the proxy server, the user wants to use a proxy server. So I need to set the access type, which is the second parameter to internet open, to true, or actually internet open type proxy. If I don't do that, I set it to internet open type direct. The SC proxy parameter tells me what proxy server to use, and I just use the buffer that I got back from that function. So internet open is real simple. I just pass it an agent string. This is the agent string that gets past the web server, the access type, and the proxy. And the last two parameters, which aren't supported on CE, are just null and 0. To go back to the top, I'll just show you the agent string. I've set the agent string to my application name, and I've been good, and I've put my email address in here because the robot access rules for this website ask that you include your email address so that they know who's accessing their page through a robot. So I've done that. So now once I've done that, I've got a couple things that my application does. Let me go back and I'll show you the example on that. So there's two things. Each web page, actually, let me show you how it looks on the internet first. That's a little better. So there's the first page I already showed you that has the weather data. One thing that I can also do is I can click on this forecast link, which tells me more about the conditions, what the weather's going to look like. And this is also interesting to me because if it's a small craft advisory, that maybe means I'm not going to go out sailing tonight. Because I don't have my device connected all the time, I wanted to download the forecast and cache it locally on my device so that later on, if I wanted to see what things were looking like, I'd still have it there and wouldn't have to dial in.
One reason why he did that. The active sync technology was premised on the fact that you sync your device when you're not thinking about it, grab the device, and go. So Dave has done the same thing in his app. When he's got the device connected, it's pinging a couple times every hour, and it's getting the data up to date, and it's getting all the data the user needs. When Dave wants to go sailing, he grabs his device and he runs to a meeting, and in the meeting he can look at the marine forecast. He can look at it in his car. He doesn't have to be connected all the time. And I'd like to recommend that that's a really good model for anything that's expecting data from an external network on a device like this.
Yeah, I'll show you an example of how this app does that in a second here. So what happens in this is when I fire up the app, a second ago you noticed that it was unknown. Once it receives that web page, it parses this data out of it. And as you can see, I've basically put a summary of the information in the dialog. So I have the air temperature. That station doesn't have the dew points. The dew point's unknown. I've got some pressure and the pressure trend. And I got the wind speed. One of the things the app does, which is interesting, if you're interested, the source code for the app we posted later, the icon in the taskbar actually changes different colors to indicate whether how windy it is. And if it's white, it's 10 knots or lower. If it's green, it means it's a good time to go sailing. And red means maybe it's dangerous. What I can do now is I can click on the forecast button here, and I've cached that forecast locally. And if I'm disconnected from the network, you can see in the address bar that this is actually a local file that I've stored in my documents path. And here's the latest forecast for that area. Let's go back and look at the code again for that. So I just put these into two separate functions, update condition and update forecast. And each one of those takes the internet handle that I've opened previously. So my update conditions, he knows I've stored the website in my resource file, so it's easy to change if the website changes. So the very first thing I do is I build up the actual path of where to locate this thing. And the website name is stored in the resources, as is the URL chunk of where to do this. The station ID is one of the options the user can set. I can show you that as well in a minute. And I just append that at the end of the URL. It's just a query that's passed to the web server. The API that we really care about is the Internet Open URL. What I pass here is I pass in my previous internet handle, and that's the handle it knows how to get to the proxy server or what type of connection options I've set. And I just give it the URL. It's very simple. I also pass in the Internet flag reload. This, on the desktop, would say don't use your entry in the cache. On the device, since there is no cache, it doesn't do anything, but it doesn't hurt to specify it right now. And if we add caching in a future version, my app is still going to work. So I just return hpage handle from this. If I actually got a handle back, now it's going to be time to read this data. I've created a simple parser that reads through chunks of data. I'm not going to go into how the parser works, but if you look here, you can see that there's very simply just a set of field names and the variable that I want to get back from that parser. How it works is I call internet read file on that handle, and I give it a buffer. The size of this buffer I picked is just 1K because I want to pull it back in streams as it comes back from the server. And this tells me how many bytes I've got back. When DW bytes read is 0, that means that I've got all the data. So I just keep reading while there's data available. And I basically pass each chunk of that onto the buffer with how many bytes, or the parser, with how many bytes he needs to parse. Finally, when I'm done reading the page in, I just close that handle. At that point, I have my data. The update forecast is very similar. In this case, I actually want to cache to a file. So I do the same, open the URL here. Up above, I build up the forecast URL. And instead of passing out to a parser, I just create a file where I store that forecast. And now, as I'm calling internet read file to get the data, I just write each chunk to my file. And then when I'm done, I close the handle and close the file. So as you can see, simple web access is very simple with this. Do you want to see it? Sure, I'll give you a quick example. And like I said, this will be put up later on. I've made it a very simple. I'll show you the header file here. I wanted something that could very simply just skip over tags and pick up data by fields. So the parser basically has a bunch of things it's looking for. Parse null indicates the end of the parse table. As you saw in the code before, I just passed the parser a list of fields I'm looking for and variable types. And what I can do is I can say I'm looking for a specific match, and I don't really need a value back. That's if something's context sensitive. Or I'm looking for a D-word, a float, and a string. And each one of these is just using an overloaded method, which is find value. And depending on the variable type, I can pass in a D-word, a float, or a tchar. It builds up entry in that table. And the parser is really just a simple state machine. Here's the main for loop looping over the data. There's a state for tag mode. Right now, I'm not doing any specific parsing on tags. This could be easily extended, though. So if I see an open bracket here, which means I'm hitting an HTML mode, tag, I go into tag mode. And down here, while I'm in tag mode, I just skip characters, and I won't match any of those. I also have a similar mode for entities. If I go into entity mode, which is, if you're familiar with HTML, it's just an ampersand, name, semicolon for characters like greater than and other non-representable characters. I skip those too. Technically, if I was looking for those, I might push those back into the input stream as a character type, but I don't do that because they didn't matter for this example. And entity mode here just basically watches for the end of the entity mode or watches for a numeric entity. Finally, the case that we really care about is find mode. And all I'm doing here is I'm just looping through I have an entry flag for the current entry match that I'm searching for, and I just see if the input string in my buffer matches up against the string in my table. And if they match, I just keep moving forward. If I get a non-matching character and I'm somewhere in the match, I just roll back and start matching again.
So a couple of comments. This parser works if you have half of the tag in one block and then the other half in the other block. But it doesn't handle the case where you get the tags out of order. So he knows exactly what the page looks like, and he's able to do that.
Right. So that's why I'm not using any kind of string compares. I keep the state, and the parser maintains the state while it's running.
But it could be easily extended if you have other uses for it.
Once I find a match for the prefix string, then I just have a bunch of if statements here that know how to parse each type. I know a D word consists of digits with plus or minus. I know a float consists of digits with plus, minus, or a period, and it just reads until it hits the end of that character type. And then once I finish matching the characters for that, it just converts it using the built-in conversion functions. So, but like I said, this code will be available. So I wanted to do something that was the simplest case, but it's certainly easily extendable.
So one last piece, you were going to go back to a sample.
All right, I was going to tell you about the update case, which Tim mentioned earlier. So one of the things, my options on my app, is I have an update interval that lets you specify how often to go back to this site. You can also specify the station ID. The way the update interval works is the application uses a timer so that I can periodically ping the website and get that data down. By default, these are specified in 30-minute increments because the data is only updated on the hour. To get around, so if I'm connected, basically it means I'm going to go get the web page, whatever the update interval is. But I've added a little bit of extra code in here. The problem I had when I did this update interval was great. When I was sitting in my office on the network, my sale data was updated every half an hour, and I was current. The problem was if I got disconnected and then came back from a meeting, the update interval might have just happened, and I wasn't going to get new updates for 30 minutes from now, even though I'm back on the network again. So what my app does is I have a special mode called poll mode that I go into if I fail to connect. Let me find the code where that actually goes into that.
F3. Oh no, you're looking for the wrong thing. You're looking for open braces, just a second.
What?
Exit poll mode? I'm not sure what you're looking for.
Actually, here it is right here. We're looking at this is the update code we were looking at before. So this is exactly where I update the conditions, and I'm actually using H results in here. So if I fail to update the conditions or I fail to get the forecast, I'm going to set my H result to E-failed, means something went wrong. If I succeeded, I have an update time on my dialog. I just have that in there so that I know how good my data is. It's important for me to know whether or not like my sailing data is 2 days old or not. If that failed, I'm going to set this poll mode into true, and then I have a scheduler which runs my background thread. So in my schedule update,
spelling error.
What my schedule update function does is it knows about poll mode. So if I'm not in poll mode, I have a couple functions that get me the time since the last update, and I do some timing conversions based on the way Windows timers work and the internal times work. If I've exceeded my update interval, maybe the app wasn't running, I just set the update for 2 seconds, so it'll happen immediately.
And that's also what poll mode does, doesn't it? Sets it to about 2 seconds.
What poll mode does, if I'm in poll mode, I just set it to a poll interval. I thought about putting this in the options of the resource key, but right now I set this to, I think, maybe 5 or 10 seconds. I was playing around with different values that weren't too difficult on the system. If you can't connect, it's very fast anyhow. The internet, the first page open will fail pretty quickly when the website's not there, so it's not too bad. I hope I'm doing the wrong thing. So I said, okay, I actually set my poll interval. I was being nicer. I set it to 60 seconds. because that seemed to be good enough for most cases. I was using 5 seconds before in a testing case, which worked, but it seemed to be overkill. Generally, if I'm online getting my mail or dialing in, 60 seconds is going to be enough to get that web page and pull it down. That's it for the communications part. We're going to move on to storage, and we're going to go through this quick because we're... Let's see. Oh, sure. Right.
Is there a way to turn that on programmatically and also terminate the existing connection?
I'm not sure about programmatically turning it off. You actually can use the RAS functions. If you do a RAS and NUM connections, you can actually find the current active connection. You can terminate it yourself. So there's a way to terminate that. I have to go back and check with you. If you stop up after, I'll look up the information on that. So a quick overview of the internal storage on the device. There's no drive letters. Everything is just simply path-based. RAM and ROM files are merged by the operating system into the same tree, although there is a special flag in get file attributes for ROM files if you care. They're also read-only, of course. The built-in RAM is used for several things. Rather than just files, it's where your programs are stored. You're certainly familiar with the slider where you can adjust program memory and storage memory. One of the things that are also in storage memory besides files is the database object store, which you can see from the database folder, and the system registry. Of course, storage cards provide more space, and as I'll mention in a second, there's a way that you can create databases on storage cards now with HPC 3.0. But basically, in terms of using storage cards, if your apps don't really need to do anything special with them, the standard open file, open save dialogues, since it's all a flat file space with no drive letters or anything special, they just appear in the file system. So I mentioned a couple things on this slide. If you really care about detecting storage cards and you want to handle them especially, the file attribute temporary flag gets set on a storage card. The shell uses this, for instance, to determine if something's a storage card and to give you free space information and to change the icon to a storage card in a handheld PC 3.0. On the palm-sized PC, there's actually a couple of special APIs that aren't supported on the HPC, and those are find first flash card and find next flash card.
If you want to use those, you need to look in the file projects.h. I mentioned that in my intro palm-size talk. But the other thing you do is you just enumerate all the files in the root file system and look for file temporary.
That'll work on both types of devices.
That will.
So that's if you want code that runs on both, you can use that.
Really quickly about the database volumes. Those are brand new.
I'm going to get that.
You're going to get that?
We're going to get to the database volume in a second here.
Okay.
Couple quick things about the registry. Everything's in Unicode. There's no user profiles at all, but you can still store things under HP local user. You should store your application settings under either HP local machine or HP current user software company product. That's pretty standard. And you're better off to save storage space to use shorter key names if you can. Don't use these really long key names for your application settings. It doesn't mean make them super short so not understandable, but just don't go crazy. So we get to databases, and we have another example for this that we'll do quick. As I said, you can store these in the object store or in database volumes and files. A CEDatabase is very simple.
A database?
A CEDatabase is very simple. It's just a set of records. And unlike databases you might be familiar with, the records are pretty much free-form. And each record is just a set of properties without an enforced schema. So this means that typically you have the same set of properties for every record. You're still free to create properties that have some record, or create records that have some properties but not others, depending on what you're doing. Databases in the current versions support up to 4 indices per database.
And that means you can sort on any index, so you have 4 sort orders on any database?
Well, actually, the way it works is, and I'll mention this, is the indices are sorts that are stored with the database, so that it means that if you want to sort by that index, it'll be really fast.
Mm-hmm.
When you create a database, you specify the index, and you can change that in the future, and we'll show you how. And also, records don't contain other records. So it's basically a flat set of tables. If you want to do multiple records or multiple tables that are related, you have to create separate databases. So database volumes are new for the HPC 3.0. This is primarily to support database volumes of storage cards. Each volume contains multiple databases. So if you have an app that deals with a bunch of related tables, you don't have to create multiple files. You can just create one volume and then create them in there. The existing database APIs have new EX functions which support this.
The only difference is the EX function takes the GUID that's returned by MountDB volume. They work exactly the same. I use these to make a pretty simple app that I don't have with me today, but I read all the databases off the device, created a DB volume, copied them all onto the DB volume, and then I could put that on a CF card. In fact, I could put it on a corporate share. And that way, for testing purposes, if I find an issue with one of our apps, I can give Dave all of my data out of my database. He can put it on his machine by reversing the operation. So they're actually quite powerful, and I encourage you to consider using them in your apps.
One thing that I don't note in the slide, which you should consider, is that if you're putting databases on the local storage or on a storage card, you're better off for performance-wise not to compress them. The system does give you an option to do that when you create it, and if you're not really pressed for space, you're going to get better performance by not doing that.
Oh, another thing, you can actually create a DB volume in the file system. It doesn't have to be on a storage card, which I thought was kind of amazing. And I do believe it works in the emulator as well, which I was also surprised to find.
So a quick overview of properties. The CE databases support your basic integer types, short, unsigned short, long, unsigned long. You can read the slide. Basically, the way it works is each property, when you're passing it to these APIs, is just a D word that contains two words. One is the property identifier, and one is the property type. So typically, your code, you're going to do something like define a constant with make long, and you're going to specify the type and the property ID. These are specific to each record, and when you read a record, you actually get back the property IDs. But for consistency's sake, you usually use the same properties for all the records in your database. Although it would be possible to have like a type field in your database which identifies what the rest of the properties are. It's not generally a good way to do that. So I think we have an example of how. You want to show the app really quick?
Yes. So basically, I created an application that lets me log every time I buy gas and change the oil in my car. And I've put all those items in a database. And I sorted by the odometer setting at which I did this. So I don't actually use the list view to do the sort. I ask the database to give them to me in order. I can create a new item, and when I create a new item, it's put both in the list view and in the database. And the database is updated. I did allow for filtering, but I did the filtering in the list view. That's about it for the database stuff. I'd like to show you some code, though, if I have a couple seconds. Mm-hmm. Since he just talked about it, I'll show you the loop I wrote for init car prop val. I wanted to read 4 values out of the database, and I was just lazy and stored them all as I2 values or integers. And I had to you'll notice I is in here, right here. So I had to set all the prop IDs to be different. If I go back and look at the other code I used that in, here's what it took to open the car database. And I wanted to highlight a couple of things here. To sort by ascending, use something that's not how I spell ascending, but it's how the database team spells ascending. And then you put in the property ID you want to sort on, and you can specify a couple, but I just chose the odometer setting and the way you want to sort and call create database. Let's see. There's a couple of things that are confusing, so I want to try to explain them without confusing myself. I wanted to create a database or open it. So if you call create database and it fails, then it exists already. That's fine. So I didn't care in this case. It returns an OID. You have to pass the OID to open database. It's kind of annoying. Now I'm confusing everybody.
Well, typically there's a couple ways you can deal with your databases. If you're creating it for the first time, you'll get an OID returned from the create call, which you can pass on to open. If your database has already been created, it won't do anything, but it will still return you the OID. And now databases are simply identified by name. So typically you don't care that your database doesn't exist. You just call create database, and it gives you the OID.
Oh, that's right.
Trace it if it's necessary.
That's right. So this line should have keyed me off on that. I don't care about the OID because I'm always going to open by name. And to get the OID, you actually call CE open database, and that returns you the OID.
Yeah, it's possible to open by name or OID. And in this case, Tim's written the code to open by name.
Right. So I did pass in another flag, the auto increment flag. So every time I seek every time I read a record, it just automatically seeks forward for me. When I'm done with the database, I call close database, but it's not right here. I think we should probably skip the rest of it and go on to the rest of your talk. The code will be available to read through the database when we're done.
Well, I'll mention a few more items about sort order in the databases. When you create the database, you actually specify up to 4 sorts. But when you're actually working with the database, there's only one sort active at a time. So when you open it, you have to choose what sort order you want to use. If you want to sort by something different, you have to close the database and reopen it with the new sort order.
Actually, Dave, you can have several handles to the same database.
Right, that's also possible. So you can open the database with several handles as well. One thing they're adding in the new version of the OS, and I can't tell you when that will appear in the mobile products, is the ability to specify up to 8 sort orders on a database and have up to 4 levels of sorts when you open the database. And that will be much nicer.
Another thing to be concerned with, though, actually changing the sort order on a database is an atomic file system operation. If you're going to support something that has 5 or 6 columns in a list view and support sorting on 4 of them because they're common cases, you have to probably use the list view to sort on the rare case, like grandma's birthday, because actually resorting the entire context database might take minutes with the file system locked in an atomic operation. So just be careful and don't do that to yourself.
Database support finding records. The CEC database is based off of an absolute positioning or searching for a value. And as you might guess, searching uses a sort order. So before you can actually pull a record out of the database, you have to set the position. When you first open the database, there's no position at all set. So you can either call CEDevCon and seek to the first record, or you can actually call CEDevCon and search for positions. And
I just called CE-seek0 so I could just list them all out.
so Tim lists has an order. He's already set the sort order to odometer value, so his records are sorted in order. And he's just going to, you want to show me?
I only call CEDevCon once. And I just seek to the beginning 0.
So our simple app doesn't have an example to look up records because you just sort through them in the list view, but it's definitely possible for a large database to go through and sort for things.
Mm-hmm.
The built-in find for the PIM context actually does that. It opens each of the PIM databases and seeks for the strings you supply. And as I said, the value uses the current sort order that you're searching for. Once you find a record and you've got the one you want, you call CE read record props. The annoying thing about this is it returns to you a list of records that are or a list of properties in the current record, but there's no order at all. They have nothing to do with the properties you created. So you actually have to scan through and pull out the properties you want. It's also possible when you read the record to specify only the properties you want in case you've got a whole lot of properties in the record. And that's actually more efficient if you're only using a small set. If you need all the properties, it's better off not to call CE read record props for each property. You should actually scan through and find them in the prop vals that are returned.
Okay. Just give me 1 second.
Okay. Well, we'll show you an example of that. For writing records, it's pretty similar. You pass it another one of these prop ID arrays, and you just basically give it the prop IDs that you define, and you pass them a value. If you specify a OID of 0 when you do this, it'll create a new record. If you specify an OID that's already existed, which you've gotten from a read, you can overwrite those records. As I said before, each record can contain any properties you want, and generally you keep your database consistent. If you want to get rid of a record, you just call CEDelete record and give it an OID. There's also in the new there's also a CEDelete database to remove a database, and you need to make sure your database is closed. There's also EX functions which work on database volumes. And again, the difference with the EX functions are they just contain an additional ID of the volume you're working with. Databases provide notifications as well, so if you have cooperating apps or if you have APIs into your databases, your app can get notified when changes take place. This is, for example, how the inbox application works. The transport that's below the inbox is writing data into the mail database, and as these records appear, the API, the user interface, is getting these notifications and updating your list view. So
in fact, on the palm-sized PC, that's how the active desktop works as well. The active desktop waits for notifications from the contacts in the tasks database and updates itself automatically. If I I found the code that I used to read the database. So I have this loop called init car prop val, and what it does is it sets up a CE prop val struct with 4 items, and it says I want to read these specific 4 properties out of every item. And then if I look at the code that actually calls it, code that fills in the list view calls reset car database to seek to the beginning, and inits those 4 values, and then calls read car record in a loop. And read car record is only going to read from those 4 properties that I've passed in, and it's down here. I pass in the 4 records to read, and then I pass in to read record props those 4 specific things to read, the number of properties to read, and I get it back actually fills it in. So what happens is it reuses the PCE prop structure. I pass in the values I want it to fill in, and it fills them in right there, but I can call it in a loop, and it will continue to read and fill in the val item in the structure. That's enough for now. The code's pretty straightforward when you look at it, in more than 4 lines at a time.
So in terms of notifications, also 2 styles. There's the original style that was used in the OS version 2.0, or the current palm-sized and handheld PC 2.0, that just sends you a message when the notification occurs. With the handheld PC 3.0, there's some new notifications that pass you an entire structure, and they have some more information. They also tell you about database volumes being created and deleted, or databases being created and deleted in your volumes. If you don't care about the new notifications, you can just use the original ones. Those are still supported.
Last slide. This is your last slide.
And finally, I have an example. This is skipping back to a little bit of communications. Just a quick example to show you how you can send email from your application. The Pocket Mail application supports a bunch of command line parameters you can use to send email from your application. So I've just used a quick example here that shows how you can insert these. And you just call create process, and you can pass in any of these flags to set up your mail. What will happen when you do this is it won't actually send it. It'll pop up a user interface that fills in all these values, and the user actually has to acknowledge the send. And I didn't go into this in this talk, but there's mail APIs that exist for you to submit things to transport and to get at these directly. That's about it. Are there more questions? Yes? Yes, I don't have it in the slide here. He asked if the code's going to be available. And we're putting the code available on the website conduits.com. Yes?
I put the URL up and the machine up on that site right now.
Again.
Well,
the question is there a way when you're dining with RAS to set up active sync and make it happen automatically?
Well, there is an item in the start menu called active sync.
Well,
based on that, I would guess it's make a call somewhere and it's a create process, and you should be able to do it yourself.
I know that you can create the you can fire up the app, but I'm not sure if there's a way to specify the parameters in that active sync dialog directly or not. I mean, again, stop up and I'll give you a card and I can try and see if it's possible or not. Yes. Is there full support?
I don't.
The question is there full support plan for the generic proxy server client? You mean for the automatic proxy detection, or for? I'm not sure. Yeah, I'm not sure if that actual parameter is supported, but it's, as I showed, it's pretty easy to get that information anyhow. So, right now the problem on the handheld PC is that information is stored separately from WinINet, and the two aren't synced out, so it doesn't know about those registry settings that Pocket IE uses. I think there's some questions at the mic.
Yeah, you mentioned that the double data type is supported. Is that true?
That what?
Double. I couldn't find any way to store double in the Windows CE database. Is that a new feature? Or? What's the CEBT code for that?
Let me just look. I can look it up quickly right here. I don't know it off the top of my head. I think the double might be, I don't see it in the docs here, but I think the double might be a new guide that's supported in the HPC 3.0. It may not be supported in the previous version. I think I'm looking at the docs here from the previous version of that.
What's your alternative if you're using a lower device? Just
I would recommend maybe just casting it to a stir and then storing it and getting it back out and getting it back
yeah,
out.
the problem is you're going to have problems for sort orders on a lower device. And yeah, it's hard to come up with a good alternative to that. I mean, you can sort it as a string, but you're going to have to certainly pad out the zeros in that. Or you could
you could store it as 2 ints, maybe.
You're still going to have a sort order problem. So the best alternative is probably use string if you're going to sacrifice storage space for that.
I have 2 questions regarding RAS. The first is RAS going to support external modems? In the documentation it says that it doesn't support external modems, only PCMCIA, although it actually does if you hook an external modem up to it.
Yeah, RAS, actually you're right. The documentation is they probably didn't want to actually support it, but as far as the RAS connection is concerned, any modem device connected to a COM port is supported. I actually use RAS over IR to an IR modem, and it works great.
All right, my other question is that I've actually used RAS, and it doesn't seem to return a lot of extended state information about the state of the connection. And even when the modem's been shut off or the connection has been dropped, it doesn't return the fact that the RAS connection has been dropped.
I'm not sure about. Come up and talk to me, and I'll try and. I don't know off the top of my head the answer to why you're not getting the state information. I know there might be a delay in some cases, but I can try and get a hold of some people who know more about that if you give me your contact info.
Okay.
Yeah, I'm trying to enable application programming on an x86 platform. And I don't know how that relates to these HPC 3.0, because we're using like WinCE 2.1.1 or 2.1.2. And so I'm questioning some of these comments here, like HPC and PPC only support HTTP. Is that also supported by the toolkit then?
Yeah, I kind of mentioned a little bit about that. The WinINet component is available for you to set in your CE sysgen, so you can actually pick. The OS supports 2 things. You can support HTTP or FTP only. So you're not going to get the things that you're not going to get support for are things like Gopher, which you probably don't care about anyhow. I don't know. Does that answer your question?
Somewhat. Now, what about things like it says HPC 3.0 adds database files. Will that be possible? Because we're using removable media.
Yeah. Well. Everything that the HPC and PPC supports are going to be available from your embedded toolkit. Okay.
And we've noticed things like ADO aren't available in that toolkit. Is there a reason for things like that not being there?
Well, a good reason or a reason?
Just reasons, yeah. I mean, how can I find out what's not available that's available in the retail version and why we don't have access to the things that the retail versions have? Because our customers are asking for these things.
I would actually ask that you direct that in the Ask the Expert session this evening with the tools team that's been giving the talks on Platform Manager. But one thing that comes to mind is that might be something that the platform team has gotten from a different section of the tools team and installed as a separate component, and that wasn't rolled into Plat Manager yet. So you might just have to get a separate deliverable. I remember we had an MFC extension pack that went with HPC 3.0 on a separate CD that OEMs had to put in themselves, and that might be why you don't see these components.
Right. There's no reason that ADO won't run on an embedded platform that you build, and the reason that it's not included with the embedded toolkit is it was developed as part of the Pocket access effort. And what's happening with some of the OS versions, this stuff's getting rolled back into future OS versions, and for instance, 3.0 may include the support for ADO. It's possible with either a separate licensing agreement that you could distribute this and use this in your application. So just come up again, I'll give you my business card, and we can work something out.
Thanks.
Any more? Okay, thank you very much.